Imagine this, a Formula One car screaming down a straight at over 200 miles per hour, yet it stays glued to the track through every high-speed corner. It looks effortless, almost like the car is defying the laws of physics. But behind this seemingly magical performance is something you can't see, but is always at work: aerodynamics. And it all starts in a highly controlled environment, the wind tunnel. In 2024, Formula One has taken a huge leap forward with Aero tunnel technology, transforming the way cars are designed for optimal performance. Let's dive deep into how these Aero tunnels are shaping the future of F1. 10. The basics of wind tunnels. A controlled environment for precision. Wind tunnels are not new to F1, but in 2024, they have become more advanced than ever before. A wind tunnel is essentially a massive tube where air is blown over a stationary car model to simulate real-world racing conditions. Engineers can study airflow patterns around the car to understand how aerodynamic forces, like drag and downforce, are impacting the vehicle. The latest wind tunnels feature high-tech sensors and data analytics to offer more precise readings, allowing engineers to tweak the car's design with pinpoint accuracy. These tweaks are what make the difference between winning and losing in a sport where fractions of a second matter. 9. Maximizing downforce, sticking to the track like glue. One of the primary goals of any wind tunnel test is to maximize downforce. Downforce is the force that pushes the car down onto the track, increasing grip and allowing it to corner faster. With the 2024 regulations, teams are working within stricter aerodynamic limits, which means they need to find every possible advantage within the rules. Wind tunnel testing helps them achieve this by identifying areas where they can add subtle aerodynamic elements, such as winglets and barge boards, that generate more downforce without increasing drag. The result? Cars that can take corners at mind-blowing speeds while maintaining stability. 8. Reducing drag, the balancing act. In F1, drag is the enemy of speed. The more drag a car creates, the harder the engine has to work to push it through the air. However, there's always a trade-off between reducing drag and maintaining downforce. In 2024, Aero tunnels have become vital in helping teams strike the perfect balance between the two. Advanced computational fluid dynamics, CFD models, are now integrated into wind tunnel testing, allowing teams to predict how small adjustments, like a slight change in the rear wing's angle, can reduce drag without compromising downforce. This balance is what enables F1 cars to achieve incredible top speeds while remaining agile in corners. 7. Ground effect revival, making the most of airflow beneath the car. One of the most exciting developments in F1 aerodynamics for 2024 is the return of ground effect technology. Ground effect uses the airflow beneath the car to create a vacuum-like effect, sucking the car closer to the track. This improves downforce without increasing drag. Modern wind tunnels are equipped with moving belts beneath the car models to simulate the interaction between the tires and the track surface. Engineers can now study how the ground effect behaves under various conditions, from high-speed straights to tight corners, allowing teams to fine-tune the car's underbody aerodynamics for maximum efficiency. 6. The importance of aerodynamic efficiency in DRS zones. Drag reduction system, DRS zones, are critical to overtaking in F1, and Aero tunnels play a huge role in maximizing their effectiveness. DRS allows a car to reduce drag by flattening the rear wing, giving it a speed boost on straights. However, it's not just about going fast in a straight line. Teams must ensure that the car remains stable when DRS is activated. Wind tunnel testing allows engineers to simulate the opening of the DRS flap and observe its effect on the car's aerodynamics. By optimizing the DRS setup in the tunnel, teams can ensure that the car remains aerodynamically efficient and stable, even when DRS is deployed at high speeds. 5. Turbulence and wake management. Fighting dirty air turbulence, or dirty air, is a constant challenge in F1. When a car drives through the air, it disturbs it, creating a wake of turbulent air behind it. For the car following, this dirty air can reduce downforce and increase drag, making it harder to overtake. Wind tunnels are crucial for understanding and managing these turbulent airflows. In 2024, teams are using more advanced techniques in aero tunnels to simulate the wake generated by rival cars. This allows them to design cars that are less affected by dirty air, giving their drivers a better chance to make clean overtakes without losing performance in the corners. 4. Simulating real-world conditions, beyond perfect weather. In 2024, wind tunnels have advanced to replicate a variety of real-world weather conditions, allowing F1 teams to test their cars under challenging scenarios. This evolution is crucial, as races often occur in less than ideal weather. For instance, a car might show exceptional performance in calm air, but high crosswinds could significantly impact its stability during a race. By simulating these turbulent conditions in the wind tunnel, engineers can observe how aerodynamic features respond to changing airflow. This testing enables teams to identify potential issues and refine their car designs to enhance stability and predictability. Additionally, they can develop race strategies that account for weather variability, ensuring their cars perform optimally regardless of the elements. Overall, these advanced simulations provide invaluable data that help teams adapt to the unpredictable nature of racing, ultimately improving their chances of success on the track. 3. The role of scale models and full-scale testing. F1 teams often start by testing scale models in wind tunnels. These models are usually around 60% the size of a real F1 car, but with advanced data collection tools, they offer incredibly accurate results. Once the data from the scale model looks promising, teams move on to full-scale testing. In 2024, full-scale wind tunnel testing has become more restricted due to cost-saving measures, so teams have to make every test count. This means that the initial scale model data needs to be as accurate as possible, and teams rely heavily on their wind tunnels to ensure that the transition from model to full-size car goes smoothly. 2. Data integration with CFD, a symbiotic relationship. In 2024, Formula One teams have made significant strides by integrating wind tunnel testing and computational fluid dynamics (CFD) simulations. Previously, these processes operated separately, with each offering different insights. Now, they work together to maximize efficiency and precision. Wind tunnel data is used to validate and improve CFD models, ensuring they reflect real-world conditions more accurately. At the same time, CFD simulations provide detailed insights into complex airflow behaviors, allowing engineers to optimize their wind tunnel tests. This integration creates a feedback loop. Wind tunnel results refine the virtual simulations, and the simulations guide more targeted physical tests. This collaboration helps teams develop more accurate aerodynamic models, leading to faster, more precise design adjustments. By combining both tools, F1 engineers push the boundaries of aerodynamic performance, ensuring that their cars are optimized for both speed and stability in real-world racing conditions. 1. The human element, engineers and innovators. The effectiveness of wind tunnel testing in Formula One ultimately hinges on the expertise of the engineers who utilize it. Despite advancements in technology that enhance the precision and efficiency of these tests, the human element remains crucial. Engineers engage in creative problem-solving and innovative thinking to translate aerodynamic data into practical designs. Their skills come into play not only during the testing phase, but also on race day, where quick decisions can influence outcomes. In 2024, F1 teams are equipped with some of the brightest engineering minds, working relentlessly to fine-tune their aero packages. While wind tunnel testing is a vital tool in understanding airflow and optimizing performance, it's the engineers' ability to interpret data, adapt designs, and implement strategies that ultimately leads to faster, more agile cars on the track. Their ingenuity and expertise are what truly push the limits of speed and performance in Formula One racing. So there you have it, the incredible ways 2024 F1 Aero tunnels are transforming the sport, pushing performance to new heights. From maximizing downforce to fighting turbulence, these tunnels are the secret behind every record-breaking lap. If you enjoyed this deep dive into the hidden science of F1, make sure to hit that subscribe button. We'll continue exploring the most cutting-edge innovations, the behind-the-scenes tech, and the jaw-dropping moments that make Formula One the pinnacle of motorsport. Stay tuned for more insights and thrilling content, because in F1, there's always something new to discover.